In this video, I'll be explaining the whole concept of SR flip-flop, and I'll also be providing information on this symbol, circuit diagram, truth table, characteristic table, excitation table, as well as characteristics equation for SR flip-flop. So watch the whole video if you want the whole concept cleared about SR flip-flop. So this is the symbol for our SR flip-flop, and this is just the symbol, and then this is the circuit diagram. As you can see, it's been made by two NOR gates. Now one interesting thing in this case is that there's one input in each of these NOR gates that has been taken from the outputs. For example, this input came from the output of this NOR gate, as well as this input came from the output of this NOR gate. So whenever you are asked that make a SR flip-flop using NOR gates, this is the circuit diagram that you have to use. And then this is the truth table. So you can see that there are three inputs, and this is the table for that three input, and I'll be discussing the main aspects about this truth table and how you can extract the excitation table and characteristic table from this truth table. So if you note that when S equals to 0 and R equals to 0, like in this case, S and R both are 0, then notice that QT and QT plus 1 are always identical. Okay. And when S is 0 and R is 1, S is 0 and R is 1, the scenario is something like this. QT is always varying from 0 and 1. However, this QT plus 1 is always 0. It doesn't matter what you have in QT, the QT plus 1 will be always 0. And as for this scenario where S is 1 and R is 0, for this you will have QT plus 1 always equal to 1. Okay. And when S equals to 1 and R equals to 1, for that scenario the QT plus 1 will always be undefined, which is marked by X. And QT is always varying from 0 1 0 1, if you notice here. Okay, now the characteristic table. As I have mentioned that when S and R both were 0, the QT plus 1 was absolutely identical to QT, just like I showed it in the truth table. Like this one, the whole thing has been simplified by the characteristic table. So when S equals to 0, R equals to 1, QT plus 1 will always be 0. And when S equals to 1, R 0, then QT plus 1 always 1. So it's just the simplification of the truth table that we just saw. And this is the excitation table. Now how did I get this one? Well, we extracted this excitation table from the truth table. Okay. Now notice that when QT plus 1 are 0, okay, like this one, QT plus 1 0, QT plus 1 are 0, then you should notice that S is always 0, like this one and this one. And as for the R, then it's 0 or 1. It's not defined, it's varying from 0 and 1. So that is why for this scenario S is 0, always 0, and R is varying from 0 and 1, so it's undefined. Okay. And when QT is 0 and QT plus 1 is 1, so just like this one, okay, so S should be 1 and R should be equal to 0, just like this. And for this scenario, when QT equal to 1 and QT plus 1 equals to 0, like this one, QT is 1 and QT plus 1 0, S equals to 0 and R equals to 1, this one. And when qt and qt plus 1 are both 1, just like this one and this one, then you should notice that s is varying from 0 and 1, and as for the r, then it's always 0, like this and this. So r is always 0 and s is undefined. So this is the excitation table. Now let's see how you can find the equation for the SR flip-flop. Okay, so this was the truth table, and we will extract the ones, each ones from the qt plus 1. Okay, so we have 1 in 2 in the second slot, and then in 5th, 6th slots, and as for the 7th and 8th slot we have 2x's, which is undefined. Okay, so just use the k map and put the ones in the respectable boxes, and if we do the k map application, then it should be taken like this. Okay, so the equation comes up to be, s plus, this r prime, because it's these two ones are in the r prime region and qt region, so it's s plus r prime qt. So that's it, you have your equation. So that was all about SR flip-flop. Now if you have any question regarding what I just said or showed, please tell me in the comment section, and don't forget to subscribe to my channel, because I'll be posting more videos about this stuff. So if you want more of these, then make sure that you do subscribe and press the bell button. Until we meet again, thank you.